Okay, this is the Honors Math 3 Unit 6 study guide for Rocky River High School, spring 2015. We're starting out with finding some different values of trig ratios from using the unit circle. In order to find sine of 13 pi over 3, I first have to find the reference angle for 13 pi over 3. So how we do that, just do 13 divided by 3. That's 4. 4 times 3 is 12. I have a remainder of 1. So that remainder would be 1/3. You just put a pi with that, and it's basically 1 pi over 3 or pi over 3. So this is the reference angle is pi over 3. Sine pi over 3. So I go to the unit circle, find the sine of pi over 3. Pi over 3 is right here. The sine is the y value, so it would be square root of 3 over 2. Equals square root of 3 over 2. Same thing for number 2. 15 divided by 4. 4 goes into 15 3 times. 3 times 4 is 12. My remainder is 3. I put a pi up there. So it's the same as cosine 3 pi over 4. Go to your unit circle, find 3 pi over 4. And there, 3 pi over 4. It's right here. So, was it cosine? Cosine of 3 pi over 4 would be your x value, so it's negative square root of 2 over 2. Negative root 2 over 2. Okay, so that's how you find the reference angle for radians. Cotangent of pi over 3, I again need my unit circle to find the x and y. So it's going to be, cotangent of pi over 3 is going to be x divided by y. I don't need the 2's, so it's just 1 divided by square root of 3. So it's 1 divided by square root of 3, rationalize, and you end up with square root of 3 over 3. 1 times square root of 3 is square root of 3, and square root of 3 times square root of 3 is 3. Cosine of negative 120, the reference angle for that is going to be 240, so I need the cosine of 240. 240 is right here. Cosine is negative 1/2. So that's your x value. Negative 1/2. Tangent of negative 600. I know I have to add at least 720, 2 times 360, in order to get the reference angle. So it's going to be 120. And when I look at the unit circle, 120, I need the tangent, so I need square root of 3 divided by negative 1. It's just negative root 3. Tangent 4 pi over 3. 4 pi over 3 is down here. Tangent, again, is going to be negative square root of 3 divided by negative 1. So it's negative root 3 over negative 1. Negative divided by a negative is a positive, so that's it's just positive square root of 3. Cotangent of 540. Let's subtract 360, and that gives me 180. So it's the same as a cotangent of 180. And that equals, go to my unit circle, 180 cotangent is x over y, so it's negative 1 divided by 0, which just equals undefined. You can't divide by 0. I'm going to make that a little smaller. Secant of 1575. So I know that's way more than 360, so I'm going to subtract 720, and I get 855, and I subtract 720 again, I get 135. So basically I subtracted 1,440, and I end up getting 135. So that's 4 times 360. So I need the secant of 135 degrees. Secant is 1 over cosine, so I'm going to do the reciprocal at this in this case, because 1 over is the same as the reciprocal. So 2 over negative square root of 2. Let's do that down here. So basically that's negative 2 over square root of 2. Whoops. That's the same. Then I need to multiply by square root of 2 over square root of 2. So I have negative 2 root 2 over 2, which just reduces to negative root 2. Okay, so number 8 is down here. This was number 1. This was number 2, in case you need to refer back to that. Cosecant of 3 pi over 4. 3 pi over 4 is right here. Cosecant is 1 over sine, so I flip the y value, find the reciprocal, and it's going to be very similar to this, only it's going to be positive. So it's just going to be square root of 2. So refer back to number 8 to do number 9. And number 10, secant of negative 360 is the same as the secant of 0. Add 360, you get 0. And the secant of 0, 1 over x. Secant is 1 over cosine, so I do 1 over x at 180, 1 over negative 1. I'm sorry, 1 over 1. I went to 180. I should have gone to 0. 1 over 1, because x is 1 at that point. So secant of 0 is 1 over the x value at 0, which is 1. So the secant of 0 equals 1. And now let's do the graphs. The graph of 3 sine 1/2 pi. Well, a in this problem equals 3, so my amplitude, this is going to be a positive graph, absolute value of 3. And then period is based on b. Well, b is 1/2. So period is 2 pi divided by 1/2. Just take that 2, multiply it by the top, and you get 4 pi over 1, which is just 4 pi. And your frequency is just b, so your frequency equals 1/2. That means you'll get half of a cycle from 0 to 2 pi, because it takes 4 pi to do a whole cycle, so that makes sense. Okay, so a is 3, that means my maximum is 3, and my minimum is negative 3. And then this, 1, 2, 3, 4, remember 0 is right here. This is 4 pi. This would be 2 pi. This would be pi, and this is 3 pi. And it is a sine graph, so I use 0, max, 0, min, 0. 0, ooh, that got a little big. 0, max, 0, min, 0. So let's connect the dots, and there's your sine graph. Amplitude, again, was 3. Period is 4 pi. Oh, sorry. Frequency is 1/2, and period is 4 pi. Graph 2 cosine 3 theta. So A is 2, B is 3. Amplitude is absolute value of 2, so it's 2. Period is 2 pi over 3. And B is the frequency, so that's 3. So my max is 2. Min is negative 2. And I have 2 pi over 3 for my period. Okay, so to get these intervals, you're multiplying this by 1/2 repeatedly. So 2 pi over 3 times 1/2, because dividing by 2 is the same as multiplying by 1/2. So this would be 2 pi over 6. Well, 2/6 reduces to 1/3, so this is actually pi over 3. And then I multiply this by 2, because multiply by 1/2, it's taken this times 2, so that's pi over 6. Well, this is going to be 3 pi over 6. That reduces to 1/2 pi, so pi over 2. Okay, make sure you go back and remember how to do those. For the first one, you'd multiply the 2 pi over 3 by 1/2, and you get 2 pi over 6 reduced to 1/3. Take half, or multiply that by 1/2, so that's pi over 6. Take the numerator, multiply by 3, and reduce. Now it's a cosine function. I'm going to use purple. cosine function, so I'm starting at max because it's positive. So max, 0, min, 0, max. And there's your graph. Last two, find the amplitude, frequency, and period for each graph, then write the equation. So you want to start by saying, okay, it's sine because it crosses the origin. Let's find out how long it takes to go through one cycle. 0, max, 0, min, 0. So there is where my one period ends. And what is that line? What line is that going through? Well, here's pi. It's divided in two parts. So this must be halfway between 0 and pi, which makes this pi over 2. So the period has to be pi over 2. Period is pi over 2. And the amplitude is the max, gives you the max and the min give you the amplitude. So the amplitude must be 1.5 or 3 halves, doesn't matter. Since we're using all fractions, maybe we'll go with 3 halves for this. Okay, what do I do to get the period? Well, you have to set this equal to 2 pi over b. I'm sorry, to get b, I mean. Pi over 2 is equal to 2 pi over b. To get b, this is what you have to do. Cross multiply, so you have pi times b equals 4 pi. Well, those pi's are going to cancel out, and you just get b equals 4. And this is a positive function because it went up, so it's y equals a. Since it's positive, a is 3 halves. 3 halves sine 4 theta. And I wouldn't mark it wrong if you wrote 1.5 there. The last one, we actually did this one in class, I believe. I don't remember which one we did in class now. So let's find out. Okay, this is going through the origin, so it's sine, but it's going to min first. So 0 min, 0 max, 0. There's where my one cycle ends. So again, that's at this line right here. Sorry, I need to calibrate it, looks like. Well, that is 1, 2, 3, 4. This must be 3 pi. So there's my period. And the amplitude, the highest it goes is 2, so amplitude equals 2. But remember, that's an absolute value, and this is minimum, or this is a negative, so A must be negative 2. Now I need to find B. So I have 3 pi equals 2 pi over B. Put a 1 there and cross multiply, so 3 pi B equals 2 pi. Divide by 3 pi to get B by itself. These drop out. You end up with B equals 2/3. So your function is going to be y equals A, which is negative 2. It's sine. And we have 2/3 theta. There's your function. And I believe that's it. Yep.